Hi, everyone. It's an honor to speak here in front of all of you today. You may have previously heard me speak on tech culture and how culture frames belonging and participation. As noted, I am founder and principal consultant at Eiara Limited. We are a DevOps consultancy based out of Wellington, and one of the core things we work on is ensuring the success of technical change by also helping our clients work on the cultural and organizational side of their DevOps journey. And today I'd like to talk to you about Docker. So Docker is a software platform that's been experiencing huge growth over the last few years. But before we can talk about it in depth, we need to ask, beyond a software platform, what is Docker? And if you ask any technical person, they'll say that Docker is containers. But that doesn't really mean anything. There's nothing terribly obvious about that idea. So, a container is somewhat similar to a virtual machine, in that it's an isolated space that has its own copies of things. And a virtual machine, like the name says, is a complete machine running inside of another machine. And being fully complete means you can run any operating system on them. This is why you can run Windows in a virtual machine, or Linux, or Solaris. This is why IBM ships a mainframe computer built on this concept, the ZOS. This is how the cloud works. But this comes with costs. Virtual machines are much slower than physical computers. They take up lots of computer memory. And because they're just computers, they get slotted into our deployment and management processes just like physical computers. So they will often get set up by hand. Containers are very similar to VMs. They isolate, just like virtual machines, but they don't pretend to be a full computer. They include just enough for the program to run inside the container. Because they're not a complete computer, they're much faster to run. But they have very different configuration procedures, which has the side effect of making them much, much harder to set up by hand. And this is ultimately a benefit. But to understand why it's a benefit, we need to ask why we're breaking from the setup by hand mentality. And we have to understand that Docker comes from the DevOps philosophy. And that philosophy comes with three specific tenets, principles for achieving our goals. The principles of isolation, repeatability, and determinism. But again, these are just words. They don't really go into what we're trying to do. Our first principle, isolation, speaks of every component of our infrastructure and insists that to the greatest extent possible, each component must not affect the other components and must not be affected by them. Our second principle of repeatability speaks of our process, and it states that what we did can be done again and again and again. And this is to ensure that every step of our process gets captured. And our final principle, determinism, states that when we repeat that process, the results must be identical. And this is the principle that makes automation a requirement in DevOps models. Without automation of our processes, we cannot guarantee deterministic results. And these principles are the guide by which DevOps defines its goals. Using these principles is how we can plan our infrastructure, how we perform and manage deployments, how we plan for failure. And from these principles, we get a technical model, which I call the three-layer model. And the three-layer model says that each layer of our deployment must adhere to the core DevOps principles. And we gain useful properties when we do this. So what are the layers? Layer one is the machine, this physical or virtually physical instantiation of our hardware. And this will be machines racked in your data centers or provisioned on Azure or AWS. And our principles insist that this must be managed by automation in order to achieve that determinism. Thankfully, there's numerous specialized tools out for this layer. And they're all built around that core idea that machines must start out as identical. Layer two is our operating system. This is the layer where the operating system is configured, not necessarily installed. And this is very similar to you've bought a new phone, and you need to download all of your apps again. Again, this must adhere to our principles, achieving determinism through automation. And it starts to include isolation, where we insist this configuration can't be affected by the machine below. And the final layer is our application, the special product that your teams are writing and delivering to these servers. Again, this layer requires we have full automation to ensure our principles are met, and requiring that we are isolated from layer two. And again, I really like the smartphone idea for this, that I can buy any Android phone, which is a layer 1 and 2 platform, and be guaranteed that layer 3, all of the apps will work and not interfere with each other. So this is the core of DevOps philosophy. And as I said, Docker is a tool from the DevOps philosophy. And because of that, it relies on and has strong expectations of adherence towards DevOps ideas. It says that containers are fully isolated because they include everything that they need, which makes them perfect layer 3 artifacts. It is not affected and cannot be affected by the underlying layers. It makes container creation resist manual setup, enabling Docker to easily fulfill the repeatable requirement from our principles, because we're pushed into creating and maintaining automation. And because we have to build containers with automation, we can test that automation. We can ensure that when we build our containers, they are always the same, every time. And Docker also gives us the feature where we can prove that what we've installed on a server is exactly the same as what we built. But none of these properties are limited to Docker. Virtual machines can be built using this philosophy, but tend not to be, because we treat them as normal machines. It becomes very easy to slot them into our existing practices, and this is when we end up with 3-week turnarounds to create a new virtual machine in vSphere. But to understand why that's a problem, we have to think about why these core principles are our focus. And the central idea to everything in DevOps is the understanding that everything will break in new and interesting ways at the least convenient time. So DevOps gives us the idea that if our systems adhere to our principles, then breakages will be less costly because we'll know we can repeat everything and get back to exactly where we were, and we'll be able to do it quickly. Failure, and consequently recovery, become cheap and easy. And this framing is the entirety of how we think about planning under DevOps, and Docker works from that position. It works to satisfy those goals. As I touched on, Docker becomes the entirety of our layer 3. Our only interaction with layer 2 is the Docker software runtime. Layer 2 becomes just the Docker software platform. There's nothing else that needs to be on that system. The Docker layer handles the rest, which means that our machines can always be cloned from one image with no manual configuration required. This means layer 1 becomes very, very simple. We could enforce hardware consistency, but it also doesn't really matter, since layer 2 and up are always guaranteed to be the same thing. And this gives us our strong isolation guarantees, requires repeatability and determinism to work at all. And using that framework on how we organize our systems, we start to see the need for technical services to achieve our goals, services that are necessary to run Docker in production. First up, we need servers that can support running containers. All the major Linux distributions and Windows Server 2016 both offer native support for containers. Docker runs on both. So this gives us our layer 1. Next, we'll need a scheduler. And this will be a tool like Google's Kubernetes, or Red Hat's OpenShift, or Amazon's Elastic Container Service, or Azure's Container Service. And these are layer 2 tools. They provide a clean and detached interface that gives us excellent layer 3 isolation that we're looking for. And finally, we need a unit testing and build pipeline. And this needs to be able to generate releases for distribution to quality assurance and deployment into the scheduler. This will be provided by tools like Travis CI or Jenkins. But this needs to be centralized somehow, because this tool needs to own the definition of a release. And this is a lot of moving parts. And while there are a lot of moving parts, on a technical level, Docker is very easy to get started with. The individual technical tools are largely solved problems. Lots of good documentation exists on how to run and install them. The developer onboarding experience is very polished. All of which leads to the complicated bit being, without our core philosophies, Docker isn't going to work. Being a full expression of DevOps means that the problems Docker solves are the problems DevOps solves. And the philosophies that underlie these technical requirements must and do impose constraints on how our organizations can work. To see how that happens, let's talk a little bit more about the scheduler. As I mentioned, a scheduler is a requirement of productionized Docker. It takes a fleet of machines and treats them as a single unit, then allows Docker containers to be deployed, and the scheduler places them automatically wherever there's space. Because deployments get placed and started automatically, there's not really a step for a human to come in and configure it. configuration has to come from the scheduler. And the scheduler was built with this in mind. And it has very strong opinions on how configuration should be delivered to the running application, which means our applications need to be rebuilt with that in mind. And having to rethink how our applications acquire configuration means that developers and IT staff now need training in how the scheduler expects to work. It means migrating all of the existing configuration. It means rethinking our entire process around managing passwords and other secrets. And because the scheduler places and starts applications automatically, the operational personnel who would have done that by hand don't. It's now handled for them. This impacts how a release gets handled, what a release even is. And on top of all of that, Docker enforces immutability of the releases. Once you've deployed something, that's it. Docker resists live changes. This makes existing practices around security like WannaCry or Heartbleed no longer work. Instead, our entire process needs to shift around to creating a new release, one that has the fixes, getting it to production as fast as possible. This requires our release process be fast, measured in days or hours, not weeks or months. And all of this implies major organizational changes. In order to support rapid releases, the developer team needs to become directly responsible for creating and supporting releases. This implies that developers own the entire build and operational process. And since Docker requires our entire delivery be self-contained as part of our isolation principle, the IT processes around patching and maintenance of servers are no longer needed. Fixes come from new releases. Deployment comes from the scheduler. So IT responsibility becomes racking new machines, maintaining the scheduler. This is more of a server ops team. It's less prestigious. It has less organizational power. They don't get to say no to requested changes anymore. They don't get to enforce a change window. Because all they do is ensure that there's capacity for the scheduler. And that is a lot less fun, since a lot of the fun of that job comes from building and maintaining and installing these machines. And that change in prestige can imply a loss of experienced and knowledgeable staff. But since the development teams will still need access to all of that knowledge, it makes suddenly a lot of sense to take those operational personnel and embed them in the developer teams. It retains their experience, it provides them with new challenges, and it supports the dev teams in making those good, fully contained Layer 3 deliverables. But this means how developer teams' work has to change. Because much of developer culture is built on siloing and we're better than you mentalities. Embedding operational staff means the developers have to learn to respect outside knowledge and skills. And from my background, this is a really hard jump for developers to make. But we also have things like backups, logging. This used to be handled by IT, but often had to be set up by hand. But it can't be done by hand anymore, because the scheduler owns our deployments. So all of these pieces now have to become fully automated, fully accessible through standardized interfaces through the configuration system. And this is just a small part of the disruption that a Dockerized approach entails. The IT team has lost responsibilities, had their priorities shift. They've lost personnel as they get embedded in other teams. A lot of how they were doing work suddenly needs to be automated. And from this, I would say that the people in charge of IT would push back a lot. It changes the scope of their department, of what they can do. It gets resistance from staff in IT as well. It threatens their existing processes. The ways that they determine whether or not they're competent, whether or not they're good at their jobs. They would say, security will lapse, will be a more risk. But we have to ask, what is our risk right now? A change control process that can take months in the face of attacks that develop and amplify in days? We can look at Equifax, who are showing us exactly what that means right now. The QA department, though, gets some really nice benefits. The process for delivering a build doesn't really change. They still get an email that says, hey, could you please go test this new thing? And when they qualify a build, Docker's immutability guarantees let us know that what they've qualified is exactly the same as what we're deploying. It fits really well into our existing release pipelines. With our repeatability and determinism principles, we can also give QA separate clean test areas with setup measured in minutes, not days or weeks. And this allows for concurrent testing with no risk of cross-contamination. The developer team sees more changes. They have to absorb those new team members that have moved in from IT. It starts requiring breaking down that I'm better than you mentality. Start considering those skills as valuable and important, which is really important because the developers are now responsible for those deliverables. So the devs have to be in the on-call rotation. And as a dev, we really, really resist being on call. But all the developers will have to be on call, not just those embedded IT people. Otherwise, you have powerless, unhappy IT people unable to support your deliverables. And how we think about security in the Docker as immutable world changes too, as I've touched on earlier. Fixes require fast builds and fast deployments. The longer it takes to make a build or qualify a release, the more risky it is. The more likely the entire release is to fail. So we need to do smaller releases. Smaller releases means faster releases, which means QA can test faster, which means the risk of a deployment goes down because we're only changing one or two things. But this affects project management because they set the release schedule, right? Because a release means features, right? But in this new Docker world, devs must set the release schedule to ensure they can meet their security and reliability needs. So project management doesn't get to set our release schedule? That sounds like they don't really get to set big feature plans anymore. Instead, we have to shift to a worldview where we decouple the idea of a release from a feature, which means that features start getting put behind feature flags in software. This lets releases make it to production with in-progress features present but turned off. It means that we get the ability to activate the feature for a small set of users. It means that deploy a new feature becomes turning the flag on for everyone. It means that roll it back becomes turn off the flag for everyone. But it also means that project management retains control of when a feature gets released, just not when the code release happens. And code releases are their own organizational change. For one, often developers in a single team will create areas of the product that they know really well, that only they are permitted to touch or change. And shifting to feature flags erodes this organizational pattern. It forces the development to be visible to everyone else. Developers like this will lose their sense of power and control. They will be upset, they will be anxious, and they will push back. Because only they'll say, know the code well enough to be able to do anything with it. This is a very risky proposition for a business. It leaves the critical path of part of the product in the hands of a single person who might get sick, or go on vacation, or leave. A lot of organizations also have multiple developer teams, and they all work on different parts of the product. And those developer teams will need to integrate at some point to make a release. And because lots of teams working on different parts of a product tend to not talk to each other, integration takes a long time. It's brittle. It's easy to break. So it takes a long time to test. And if the test fails, the integrations will have shifted because the developers don't stop working. So the next time it takes even longer to test, even longer to make a release. And the release taking longer means that it takes longer and longer for security fixes to make it to production, which makes everything that much riskier. But it also means that some teams end up with power over others, because teams have varying release schedules. You can't ship until we're ready, until we decide to ship, because you're relying on our features. And well, surprise, we changed something. And this doesn't work in a world where we're aiming for small releases done frequently. So instead of performing a costly integration, we have to shift to teams providing interfaces, the extremely stable technical contact points between the teams. And these work to ensure that visible changes are minimized. And you might have heard of this model because Amazon famously used it to create the cloud. But this shift also comes with a huge cost. The teams are no longer able to view themselves as the single important part of a product, only as parts of a broader whole. It changes their identity as a team and their sense of being able to get things done. And any one of these shifts would be a huge change. And shifting to a full DevOps workflow that enables Docker is all of them at once. It demands a dramatic rethinking in how our software gets developed, delivered, and supported. It asks that our teams radically reconsider how they deliver value, how they view their own capabilities, which means the cultural and organizations that come from moving in these directions are huge. They will be difficult to manage. And how to manage them is a difficult question, because it will take time, it will take a while to make these changes. 18 months, 24 months, longer. It makes people anxious and upset. It undermines their sense of what their job is or is allowed to be. Undermines their ability to feel confident or competent. So I can't answer how for you. Every organization will be different. But I can tell you that there are people in your organization already very excited by the ideas of DevOps, by Docker, by moving in these directions. They want to make this possible. They can be those core drivers and start having those difficult cultural conversations. I can tell you that there will need to be flexibility in feature release schedules, extra time to build and analyze new tools, to explore and experiment with new processes. It needs to be in the roadmaps and the sprint plans, because people told or asked to make a change and not given space will not make that change. Because the processes we already know are predictable, even if they're inefficient. We know how long it will take. We can plan to that. And when we change our processes, we lose that predictability, and all of our careful planning falls apart. And I can tell you that it's difficult to see the value in these changes, because they are deeply disruptive. They ask for reconsidering everything that we do. And it's easy to say, but isn't what we do good enough? And the answer to that question is, how important is resilience to my organization? Because that is everything that Docker, that DevOps is trying to do, to center that failure is inevitable. And by accepting its inevitability, it means we can make it less painful, make deployment less eventful, make recovery less eventful, even to where something breaking doesn't matter, because it can and will be replaced automatically. And beyond the improvements to resilience of our processes and our deliverables, the idea of DevOps has been around for almost a decade. Docker is growing by leaps and bounds, which means we're moving towards a culture where training for new devs is including DevOps. DevOps is a growing part of the Summer of Tech program. We're treating it as the standard approach, just like we do with Agile. And organizations that don't use DevOps philosophies are starting to look less attractive. And this isn't a problem yet, but it will be soon. And that's worth considering as you're doing your planning over the next few years. So that is the core of Docker. Beyond a technical platform, it offers us ways to rethink our organizational practices in the face of new and considerably different technical challenges. When we rethink those practices, we're able to see new and powerful properties that become available to us. This enables us to consider how we provide for resilience in the face of failure, new ways to consider the risks that are inherent in our existing processes. It lets us ask new questions of our organizations, of our values and intents, if we're even achieving our goals. These are the questions that let us ask, is Docker worth it? And even though it's not free or even cheap, I think the change is worth it because we gain resilience and flexibility. We can face new challenges and meet new opportunities. And through asking, we can become the organizations that we choose to be, not just the ones that we have become. And knowing all of this, I hope that you bring Docker to your organization. Thank you.
You were right. It was within 30 seconds.
I'm good at this.
Well, thank you very much, Aurynn, for that fantastic presentation. Yeah, a different perspective on DevOps, and that's fantastic. So thank you. We have a wee gift for you.
Oh, thank you very much.
Yeah. Now, we have about 3 minutes for any questions. If anyone has, please go up to the site, put them on there. Like I say, we've got about 3 minutes before we head downstairs for the closing keynote. So, yeah. Okay, what the heck? What's your question, mate?
My organisation needs to adopt Docker. Do they need to do all this stuff?
The question was, his organization needs to adopt Docker. Do they need to do all of this stuff? Not all at once, but you're going to end up with all of it at some point. And this is why it will take 24 plus months to achieve everything. As I said, it does require rethinking your build process, rethinking how you deploy things. You can deploy Docker into production environments without a scheduler, but you're just rewriting a scheduler in order to do that. And that's kind of like a lot of how we do the Docker without the Docker ecosystem, is we're doing the thing they're doing, just now we have to maintain it ourselves. So you will eventually end up doing everything.
So can anyone help us with a manual Docker stuff? Get us started?
There's, as I mentioned, lots of great documentation online. Google manages, the Google Cloud is built on top of Kubernetes, which I mentioned. So that is the Google reference Docker scheduler system. So you can read the easy to get started with Docker Dev documentation and start pushing into the Google Cloud almost immediately. That's really quite straightforward to get going with. Yes?
How do you deal with connection string settings in different environments?
Sorry, I couldn't quite hear that.
How do you deal with like connection string settings in different environments? You've got one image.
Connection.
Different connection strings. How do you deal with different connection strings?
So substituting
environments
variables.
like DFQA.
Right, so the question was, how do we deal with different connector strings between different environments? And this is where the scheduler comes in, because the scheduler, Kubernetes for instance, comes with a tool called etcd, which is the central configuration point. So you would have a cluster for dev, a cluster for staging, a cluster for prod, or multiple of each. And each one would have its own configuration, which would allow your apps to draw configuration in the same way in each environment, but retain that isolation and separation. Yes?
So compared to the conventional virtual machine, if we're doing like the staging server and the continuous integration all correctly, is it compared to that, if the Docker have any performance gain or cost benefit for the organization?
Are you hosting VM? Or the question was?
We're hosting our VM on the Azure as well.
Right.
Yeah.
So the question was, is there a performance benefit to using the Azure Container Service over Azure VMs? Not really. A lot of the performance benefit comes from running, the performance stuff comes from if we're running Kit on our own in our own data centers. In the Azure world, what you get out of it is more of a, more of a maintenance bonus versus a direct performance benefit. And if you're already doing continuous integration into VMs, you're like 95% of the way there. Docker will clean up some of it, but you're pretty much there already.
We're all good.
Well, out of time?
Yep.
Lovely.
Nice.
Thank you all very much.